So these are the sorts of problems you would most likely see in the quantitative part of the exam. Is that a big enough hint? So I have task A. The task time for task A is 35, we'll call these seconds. Yeah, there's seconds. You'd also be told they want to create 40 radios per hour. All right, what is the first thing we do here? It's really a 6-step process. What's step number 1?
Task time.
Okay, we find out our total task time. And we just add all these up, so there's, let's see, 80, 100, 115, 175, 205, 210, 240, 285, 290, 300. What does that tell us? Put this into nice, simple language for me.
It takes 300 seconds for a radio to be manufactured.
Right on. So from beginning to end, it takes me 300 seconds to create one radio. Okay? What do we do next? Go to page 65 of your textbook. You might know. We need to create a diagram, right? What's the diagram do for us? It helps us understand what has to come before what. So just nice visual thing that says, here's task A, and task A takes 35 seconds. I don't have anything coming before task A, nothing preceding. Task B and C, I have to do task A before them. Task B takes 40 seconds. Task C takes 25 seconds. D is 15 seconds. I'm gonna run out of room. E is 60 seconds. F is 30 seconds. See, I thought that was clever, pulling the board down.
Yeah, G.
G plus.
Oh, yeah, thank you. That wasn't so clever. H is F and G. Okay, good. What does this diagram tell us?
The flow.
One more time, Rilla. Yeah, no, right? I used to do assembly line balancing and project management on the same exams, and you would not believe how many people got confused. This is slightly different than project management. In project management, we would then find the critical path, figure out how we can shrink that critical path. This is a little different because all this is telling us is the sequence of events we have to do to make our radio. So this might be putting on a dial and putting on a faceplate. And what this is telling us is one doesn't have to come before the other on these. We can do them at the same time. In the same station, maybe, right? But they have to be done sequentially in order because this is an assembly line. Yes?
So can you do them simultaneously?
No.
Oh.
It's an assembly line, so you have one station right next to another. It's just telling us, what do we have to do first in our assembly line? And this is saying, okay, neither of these has to come before the other.
You
Right.
take your pick, basically.
Yeah, we'll see how to do that in just a second, okay? What's the next thing we need to figure out? Tack time. What is tack time?
This is number 3. It's 2 draw picture, 3 is tap time, or does that matter?
Yeah, this is 2. And on page 65 of your book, it actually would list this as 4 because 2 and 3 are this put together.
Tack time is your total seconds in the day over how many units? Or I guess I'll do hours, total seconds an hour over how many radios you make per hour.
Okay, so it's the amount of time available, and I'm reading right from the book here, divided by the production volume. What does this mean? How much time do I have available? Yeah.
Is there a way to 24 hours?
Well, normally it would be, but what are we trying to do in this problem?
1 hour.
1 hour. So we have 60 minutes. These are in seconds though, and we want to get everything consistent. So we would go 60 minutes, and there's 60 seconds in every minute, right? And we're going to divide that by a volume. We want to make 40 radios every hour. 60 times 60 is 360? 3,600? Okay. 3,600 divided by 40 gives us what?
90.
90? What's that tell us? To make 40 radios in an hour, I have to make 1 radio every 90 seconds. Why do we do assembly line balancing? How long is it taking us to make 1 radio right now? Yeah, 300 seconds. So we're not quite up to snuff here, right? So, next step. Theoretical minimum number of workstations. This is where I think you were going last time, right? Lots of T's here. It's our total task time from 1 divided by our tack time. Yes?
The tack time also, cycle time.
Cycle time, tack time, same thing. Yeah. Okay, so we have our cycle time here, our C, or our tack time. total task time divided by tack. So our total task time was 300 seconds. Our tack time is 90 seconds.
3.3 is rounded to 4.
Okay? So we get a 3.3 and we're going to round that up to 4. Which means what?
4 workstations.
At the minimum, I'm going to need 4 stations. Well, let's think through this. What happens if I came up with a solution to this problem and said, I can do this in 3 stations? Yeah, why? What's 3 times 9? 3 times 90? 270, and how many total seconds is it taking me to make my product? So I'm going to have a radio like with no dials on it, no antenna, no something, because I didn't have enough time to put them on. Right? So I have to have at least 3.3 stations, and really I can't have a third of a station, so I round up to 4. Yeah.
And that's all based on the assumption that we can't decrease our tax time.
Right on. Yeah, but this stuff is solid. We haven't had to re-engineer anything. All right? Okay, what's next? Now we figure out which station goes with which. How do we do this? Well, generally you're going to be given 2 rules. One is your primary rule, and that's a grouping rule. How are we going to group things together? And on this, we're going to use longest task time. And just to be clear, your tack time sets an upper boundary. You're not going to go over 90 seconds. If you go over 90 seconds with your tack time, what happens? Yeah, you're not going to make enough, right? So if we go over 90, we're not going to be able to make enough radios in a day. So we're going to take the longest time. So we're going to take the time that is as close to 90 as possible without going over. We're going to group those stations together. Secondary rule might be most stations. What the secondary rule is for is if I have a tie. So if I have 2 groupings that are exactly the same, and one has a they're exactly the same, but one has 3 stations and one has 2 stations, I'm going to pick the one with 3 stations. I'm going to pick the one with the most stations. So, and generally speaking, you'll be given these rules. So what do I do with these? What's next?
Use them to group the workstations.
Okay, so let's group our workstations. And we're trying to get as close as we can to 90 seconds without going over 90 seconds. What do we have here? 35 and 40 is 75. Look at this, I could go 80, 90. No, why?
You gotta just use one.
Yeah, because in order to do D, both B and C have to be done. So I could do 35, 40, and I'm at 75. Can I add anything else to station 1? No. So this becomes station 1. All right, what do I do now?
Dr. Webb.
Yeah.
I was going to ask, the fact that they're simultaneous doesn't affect the time? Doesn't mean you
These are not
consolidate.
simultaneous. So again, picture in your mind we're on an assembly line. So stuff is going from one station to the next station to the next station. All this is saying is not that they can be done at the same time, but after you're done with A, you could do either B or C. And before you do D, both of these have to be done.
Thank you.
Yeah. Okay, what's next?
So would C and D need to be a workstation themselves, or I guess C, D?
Let's take a look, right? So we have 90 seconds to work with, and we're trying to maximize our time. Could we do C and G? So that would get us up to 60. D would get us up to 75. Right? And we have up to 90. Is there any other grouping we could do?
No.
Next one's really easy. Why? Nice. We got one that's 90. And we know just by looking, we kind of did a pretty good job on this in terms of efficiency. How do we know that? Yeah, we hit our theoretical minimum. The theoretical minimum is just what it sounds like. It's the minimum number of workstations you need to make this work. We hit that this time. That's not to say we couldn't do this and have 5 or 6 workstations. That happens a lot. But 4 is just the minimum number of workstations you can have. All right, good. So what does this tell us? What are we saying? Yes?
Oh, I just have a question.
Yeah, sure.
Why didn't you do like A, B, and D, and why could you only do 75 seconds and not add any more time to that?
If this was not here,
Yeah.
I could have done D.
Oh, but since they both have to be finished.
Yeah,
before-
B and C both have to be finished before I can do D. Okay? Yes.
Did you turn ACP the first station?
If it didn't, 70, 95, yeah, you could if it didn't break your, this broke the time. Right, it's 95 seconds, so you got 35 and 35 is 70 and 25. If that would have been 20, the answer would be yes. You could do ACG. Because all precedence is met. For sure. Okay, yes?
So does this mean that you are going to make 40 videos in an hour?
Well, let's look at that, right? Because what do we have to do? Every 90 seconds, a product has to fall off the end of the line here at I. And right now, this is 90 seconds. Which means if we pace everything to exactly 90 seconds, right on, right? We're right at 40 per hour.
So you don't have to figure like the first one is going to take a whole, or like there's going to be an extra 4 rounds of 90 seconds to get that last one through or something like that.
What we do is we actually pace everything at 90 seconds.
I just mean your first one, you're going to start it at A, it's going to take 90 seconds.
Right,
You're going to pass it off to station 2, and station 1's going to start another one.
right.
So you're not going to get one falling off the first.
We kind of make the assumption that the line is primed. In other words, the line's full when you start from the day before. Yeah, otherwise we'd have that lag time of getting one all the way through.
Don't the 90 seconds like build on top of each other?
What's that?
Don't the 90 seconds like build on top of each other, so station 1 will take 90, and station 2 will also take 90?
Yes. So what's happening, as one is leaving station 1, it's arriving at station 2, there's one leaving station 2 going to 3, there's one entering station 1, so it's exactly what you think of an assembly line. It's a conveyor just flowing down, and one is arriving there every 90 seconds, you're doing your thing, going back, doing your thing again. Does that make sense? Okay. Yeah.
So you're saying that the reason why it's every 90 seconds is because we are already assumed we're assuming it's already full, and so as soon as we hit the on switch and each station's already full, we're going to get our first one in 90 seconds.
Yeah. And why is it every 90 seconds again? Why do we want one to fall off the line every 90 seconds?
Because we need that to be able to reach 44 hours.
We want to make 40 an hour. Could we speed this up?
Not really, because we got 300 seconds of task time.
Okay.
Well, some of them are capable of speed it up, but yeah, 75 seconds.
You gotta ball over.
We're just pacing it out to 90.
Yeah, we can speed it up with more stations, right?
So that's
What happens? Why would we not want to do that?
Station 3 is at 90 seconds. If you do the other ones faster, it'll all build up.
Yeah, the fastest we could do this is 60 seconds per station because of E, right? What would be the problem with that? Yeah, our demand's only 40 an hour.